Hello friends, welcome to Learners Forum. So as a continuation, let us see the elemental behavior of circuit elements now. So in general, we can consider the RLC, resistor, inductor and capacitor. So these derivations and these values have already been done in the first video. Now let us see the summary of this elemental behavior alone. So when we consider the value of resistor, so in terms of voltage and current, we can characterize it by V is equal to IR, and from which we can calculate the value of current, which is equal to V by R. Next, in terms of inductance, again to calculate the voltage across the given circuit, V is equal to L into di by dt is the formula, and to calculate the current flowing, I is equal to 1 by L into integral of V into dt. Next, in terms of capacitance, the voltage across circuit is equal to 1 by C into integral of I into dt, and for current is equal to C into dV by dt. So these are the relations between voltage, current and the elements RLC. Now let us see the combination of all these elements RLC whenever it is considered in series or parallel. First connection, let us see it for series. So when we consider n number of resistors which are connected in series now. Series in the sense the output is connected to the second input. So in this way it is connected. We have R1, R2, R3 till Rn number of resistors. So for this condition the equivalent resistance value will be simply equal to sum of all the resistance value, which is R1 plus R2 till Rn. For example, if we have only 3 resistors connected in series, then the equivalent value will be R1 plus R2 plus R3. So this is the equivalent resistance value. Similarly, when we consider it for inductance, n number of inductors are connected in series in this way. So the equivalent value of inductance is equal to sum of all the individual inductance L1, L2 till n number of L value, that is Ln. When it is connected in just 3, similarly to the resistance value, we will have L1 plus L2 plus L3. Next, for capacitance, so n number of capacitors are connected in series. Now the equivalent value will be 1 by C equivalent, that is reciprocal is to be taken here. So 1 by capacitance equivalence is equal to 1 by C1 plus 1 by C2 till 1 by Cn. So if we consider only for two capacitance, then it will be 1 by C1 plus 1 by C2. Simplifying it, we will get C1 plus C2 divided by C1 into C2. This is the value of 1 by C equivalent. So to get the value of C equivalent, we have to take reciprocal, which means we will get it as C1 C2 divided by C1 plus C2. So other thing we have to remember whenever the series connection is available in resistor is, whenever it is connected in series in this way, we can see that same current I flows across all the resistor value. So the current value will remain the same, whereas in terms of voltage, the total voltage passing across will be equal to sum of all the individual voltages, which is V is equal to V1 plus V2 till Vn value. So the equivalent resistance R equivalent will be equal to the greatest of all the resistance value, that is R equivalent is greater than R1, and similarly till Rn value this equivalent resistance value will be the greatest. So this is the basic characteristics when it is connected in a series way. Now let us see for parallel combination of elements. For the first condition is resistor is considered. So resistors R1, R2 till Rn are all connected in a parallel way. So in this condition, the equivalent resistance will be 1 by R equivalent, which is equal to individual reciprocal value of 1 by R1 plus 1 by R2 till 1 by Rn. In case if we have only two resistors which are connected in a parallel way, then it will be 1 by R equivalent, which is equal to 1 by R1 plus 1 by R2. If we simplify it, then we will get R1 plus R2 divided by R1, R2. This is for 1 by R equivalent, which means R equivalent will be equal to R1, R2 divided by R1 plus R2. So this formula will be very important because in many problems we will be using this. Next, if we consider for inductors, again the same thing like the resistor value. So 1 by L equivalent will be equal to 1 by L1 plus 1 by L2 till 1 by Ln. So the net equal value is 1 by, which means we have to take the reciprocal to get the value of L equivalent. And lastly, for the third element, capacitor, when n number of capacitors are connected in parallel this way, the equivalent capacitance will be equal to simply the addition of all the individual capacitances C1 plus C2 till Cn. So the important thing to be remembered in terms of parallel connection is, like as we have seen in for series connection, here in parallel type, here the voltage between each resistance will be the same. So we will have same value of V for all the resistance, but in case of current, the total current I will be equal to sum of all the individual currents like I1, I2, I3 till In across the n number of resistors. Here the R equivalent, that is the total equivalent value of resistance, will be less than the R1 value, and similarly R equivalent will be less than the nth resistor Rn value. So this is the basic difference between a series and parallel connection.